So here we're getting into doing some chemistry. And the most important thing, and maybe the thing that 10, 15, 20 years from now, you probably remember vaguely about AP chemistry and chemistry in general, even if you don't go into chemistry, is the concept of the mole. In fact, when parents come back for meet the teacher night, when they see Avogadro's number up on the wall, they remember doing calculations with the mole because it's so central to what we do in chemistry and even AP chemistry. So the mole is all about knowing how many particles we have. When we are thinking about the number of particles, we use the concept of Avogadro's number and the mole, which is either 6.02 or 6.022 times 10 to the 23rd items. So we can use that to count anything, but we normally use it for atoms, ions, molecules, and particles because it's such a big number. Counting anything else doesn't really make sense. And the reason that that number was chosen was it was the connection between a measurable quantity of grams to kind of an abstract quantity that we couldn't see, but we wanted to count, which was individual atoms. So when I say I have 1 mole of something, it does mean that I have 6.02 times 10 to the 23rd of that thing. But that number was chosen because of the idea of moles and specifically molar mass connecting to the elements on the periodic table. So we've got 118 elements. They all have atomic numbers telling us how many protons are there, which is equal to the electrons in a neutral atom. And then most of them have neutrons as well. Well, all of those things together, especially the protons and neutrons, give the atom's mass. And when we have an individual atom, it has an atomic mass. That is how much that atom weighs. And a unit we use for that a lot is AMU, atomic mass units. And it's a very, very, very tiny number. We can't measure it in the lab. We can't measure it in the classroom. It's way too small for us to think about. And it's got dozens of zeros leading at the front of it in terms of grams, kilograms, or pounds. But the connection between that number, 12.011 for carbon, or for uranium, we're in that 230 range, is Avogadro's number, which converts it to grams. So if we think about this kind of as an equation, the number of moles of an item we have is, we can think about the connection between the grams of the sample divided by the mass of a whole mole of that. Most of the time, when we're thinking about amounts, we think about them in terms of moles. We don't have to go all the way to atoms or to molecules or to ions or particles. We can make the connection between mass and moles by using that number on the periodic table, defining it as the molar mass. And when we use those numbers together, the idea of Avogadro's number, but more importantly, the molar mass, we can make connections between the measurable and those that aren't measurable, like number of particles or even moles. So hopefully this is something you feel like you have a foundation on, but we're going to practice it here and then just continue to build stronger and stronger. If there's something about Avogadro's number, atomic mass, molar mass, or why these numbers are important and related to one another, we want to practice that and get that fixed up or get that confirmed right now so that we can know how to use it going forward. Each time I have a set of problems, you're going to see that in a separate video where I go through the problem, all the work, and the answers. So that's something you can be working on with me. You can do on your own and just check the answers, or you can hear me work through those problems.